Hassan's Maths channel. I'm now answering question number 7 from the June 2024 Pure Mathematics P2 paper from the International A-Level Edexcel exam. And this question here is about equations of circles. So here they've told us the equation, or the circle, sorry, C1 has equation x squared plus y squared plus 8x minus 10y is equal to 29. And we want to find the coordinates of the center of C1 and also the exact value of the radius of C1. So the exact value of the radius of C1. Okay, and it's important for us to understand. So now basically the equation of the circle, when written in the form x minus a squared plus y minus b squared equals r squared. This is like the general equation for the circle. If it's written in this form, then the center of the circle is what the x value that makes this bracket 0, which is a, the y value that makes this bracket 0, which is b, and the radius, of course, is going to be the square root of this number on the other side, which is the radius r. Okay, so if we rewrite this in this form, we will be able to directly read from it the center and the radius of the circle. So what we need to do is we need to basically think about how to complete the square for these terms. So I'm going to write the x squared plus 8x together. I'm going to write the y squared minus 10y together. And that's equal to 29. And then I'm going to complete the square for each of these. So x squared plus 8x. X squared plus 8x. To complete the square for this, as we should know from P1 very efficiently now, you're going to have x plus 4. You always write half of the coefficient squared. So this is going to give me x squared. It's going to be plus 8x, but it's going to give me also plus 16, which I don't need. I just want x squared plus 8x, so I've got to take away that 16. And this now is the same exactly as what's written above it. These two are exactly the same. These are equal to each other. And similarly, for the y squared minus 10y, I'm going to write my square bracket. So I'll put plus y minus 5 squared, half of the coefficient. If I expand this, I'm going to get y squared minus 10y and plus 25. Of course, we don't want the plus 25, so we've got to take it away. And we can see from this that basically this is exactly the same as that. They're exactly the same. And that is equals 29. Okay, so now what we're going to do is we're going to add these two together. So we got 25. If you add it to 16, you get 41. It's going to be negative 41. 25, 35 plus 6, 41. That's right. So you have x plus 4 squared plus y minus 5 squared minus 41 equals 29. I'm going to add 41 to both sides. You have x plus 4 squared plus y minus 5 squared equals 29 plus 41. That's going to give you 70. 29 plus 1 is 30 plus 40, 70. So now we have it in the form that's required for us to simply read off the center, which is going to be basically the x value that makes this bracket 0, which is negative 4. And for the y coordinate, it's the y value that makes this bracket 0, which is 5. And for the radius, it's going to be the square root of 70. The square root of 70, there's no perfect square in this. So that's simplified third form. You can check that by taking your calculator and putting the square root of 70 in there. And you see it doesn't simplify. So that's root 70 is the simplest form. So basically, that's the exact value of the radius, and those are the coordinates of the center of C1. So there's the answer to A, part 1 and 2. Okay, so now for part B. It says the circle C2 has the equation x minus 5 squared plus y plus 8 squared equals 52. Prove that the circles C1 and C2 never touch nor intersect. Now, some people might look at this question and decide that it's got something to do with solving the two equations simultaneously and then trying to prove that they don't intersect by ending up with some sort of quadratic equation and showing that the discriminant is less than 0 or something like that. But that would be a bit too much to ask for just 3 marks. So an easier way of dealing with this is just to think about where the center of these circles are. So for C1, okay, we have the center is minus 4, 5, and the radius is the square root of 70. Okay, and for C2, we can read off the center straight away from this. It's written in the required form. It's going to be the x value that makes this 0, which is 5, and the y value that makes this 0, which is negative 8. Okay, so that's the center. And the radius is going to be the square root of 52. Okay. Now, what we're going to do is we're going to just think about, I'm going to make a little sketch just so you can visualize what I'm doing here. So let's say that's our x-axis. Let's say that's our y-axis. So for C1, the center is negative 4, 5. So somewhere over here, let's say negative 4, 5. Sorry, it's going to be a bit higher up. We don't have to do this to scale or anything. I'm just trying to make it a little bit more realistic. So negative 4, 5 is going to be somewhere over here. Negative 4, 5. Say somewhere over here. That's the center of C1. Okay. So that's negative 4 and 5. And for the next one is 5 and negative 8. So 5, negative 8, so a bit further down, just to make it a bit more realistic. So that's going to be 5 and negative 8. Just say it's down here. So that's the center of C2. That's the center for C1. This is the center for C2. Right now, we know the radii of both of those. Okay, the radius of this is root 70, and root 70 is like something just bigger than 8. And C2, its radius is root 52, which is it's going to be basically something just bigger than 7. So basically, if I find the distance between these two, points, and the radius of C1 and the radius of C2 are less than the distance between these 2 points, okay, then the circles won't touch or intersect. So just to illustrate that, supposing I was to draw a supposing I was to draw here. So that's like 5. Root 70 is a bit more than 5. So something like this. Okay. And I was to draw a circle over here. Now, if the two circles, if the radius of this plus the radius of this is less than the distance between the two centers, then they won't touch. But if the radius of this circle, supposing the radius of this circle plus the radius of the next circle, if they're such that, let me just do this so that, if the radius of this circle plus the radius of this circle are more than the distance between those two, then they will intersect. Okay, so that's how we can show whether they intersect or not. All right, so these are not accurate diagrams or anything, but that's how we can prove that they do intersect. So we need to find the distance between the two centers. So we need to find the distance between C1 and C2 centers. So the distance between them is going to be given by the length formula, which we know is the change in the axis. You have minus 4 minus 5 squared plus 5 minus 8 squared. So it's going to be 5 plus 8 squared. That's going to give you, that's going to be 9 squared plus 13 squared. Okay, the square root of 9 squared plus 13 squared. Yep. So what does that give us? The square root of 9 squared plus 13 squared. That's 5 root 10 in simplified third form. Okay, so that's the distance between them. And we know that the sum of the radiuses, so we can say the radius of C1 plus the radius of C2 is root 70 plus root 52. Okay, now root 70 plus root 52, does that give us a simplified version? Root 70 plus root 52. Okay, so what I'm going to do is I'll write this in its decimal form. That's going to be 15.57, 15.6. 15.6 is 3SF, and 5 times root 10. 5 times root 10 is going to give us 15.81. 15.81. So you can see we can write down as the distance between the centers of C1 and C2 is greater than the sum of their radii. The circles will never touch. The circles will neither, as a question word, neither touch nor intersect. Neither touch nor intersect. Okay, so we can see here that the radius of C1 plus the radius of C2 is less than the distance between C1 and C2 centers. Okay, this is C1 and C2 centers. We can say something like that. So that's basically what we have to show there, and that will basically be enough for us to get the full marks for this question. Okay, so there's no need to do an algebraic method. Okay, for just 3 marks, it's going to be very complicated to solve these two simultaneously. This is much simpler. Okay, so that concludes question number 7 from the June 2024 Pure Mathematics P2 paper from the Edexcel International A-Level Exam. Other questions from this paper can be found in the playlist, which will appear on the top right of the screen at the end of this video. Other questions from the topic of circles, equations of circles from P2, you'll find in this playlist. You can subscribe to the channel by clicking on this link, and on the top here you will find a video which shows you how to use the channel to find what you're looking for. Thank you for watching, and see you.